All right, everybody, this is Duke with a video on servos, how to center your servo, and how to basically set up a push rod to control your surface of your airplane, whether it's an aileron, elevator, rudder. If it's a control surface, you're going to control it with a servo. This video should help you out, and this will help with both the Outlaw build and the FT Explorer build, or whatever other builds there might be in the future. I don't know what the future holds. At the time of recording this video, this will help with the planes that we're building in class. So here on the table in front of me, I have some supplies. You will need these supplies or similar ones in order to do this process. Add one more thing, a couple more things in here. Actually, I forgot to put on the screen here. Okay, so we have a set of needle nose pliers. You might have some of those at home. Okay, that will be really helpful. You don't need a pair of Z-bend pliers. We have one in the lab, so I'm going to show you how to use it, but you probably don't have a pair of these at home. They're pretty specialized. They're not very expensive, just no one's going to have these laying around unless they do RC planes. Okay. I'm going to have a battery or my wall power supply. Just need some kind of power source for my ESC. Okay. So whatever ESC you have you're using, just as long as you can plug it in, then you need an ESC. So we can power our receiver. Okay. You need a receiver that's bound to your transmitter so you can control servos later on. Okay, I'll put that off screen now. And then of course you'll need a servo. Okay, this is how the flight test ones come, and a push rod. Okay, if you're building the FT Explorer, you already have push rods in your kit. If you're building the Outlaw, you'll need to use some of the push rods we have in the lab, or purchase your own. Okay, I have the two different camera views here, kind of from below and from the side. Hopefully that helps a little bit. I don't know if that's super helpful. I wish I had an overhead camera that was better than this dot cam, but we'll see how we do here as far as getting a good view for you guys. Okay, so when we're putting servos into our plane, the first thing we want to do is open up the servo box, right? So I'm going to go ahead and pull this open. This is how the flight test servos come. Most servos are similar. All right. Okay, we have our little bag here of components and parts. I'm going to try to get a little bit closer here so we can see what's in the bag a little bit more easily. Okay, here's our bag. Okay, if we open this up, we have a couple different things. We have our servo itself with the wire kind of wrapped up around it. Okay, so there's our one servo piece there. We have another little baggie here with some servo horns. These white pieces are called servo horns. And then we have some screws. And put the bags aside. So here we have, 3 servo horns and 3 different screws, or 3 screws. So what happens is they give you different servo horns for different applications. In this class, unless you do some kind of different modification, you'll pretty much be using this asymmetrical horn. Okay, but if you lose that one or something, you can always take one of these symmetrical horns and cut off half of it. These are just made out of nylon, I think. Pretty easy to cut with a pair of pliers or something like that. Okay, there's a servo horn that will end up going on top of the servo. Okay, to allow it to move something back and forth. Okay, so we'll use that asymmetrical one in our application today. But again, if you lose this one, you can cut one of these in half. Cut off the other arm, I should say, not cut it in half. Cut off the other arm so it just has one arm. Having 2 arms doesn't really get hurt as long as it doesn't get in the way of anything on your plane. Then we have these screws, and the way Flight Test does it is pretty nice because they have different colors, the black screw and the 2 silver screws. Other servo manufacturers might not have different colors, but typically if they send you screws of different sizes, you can kind of deduce what they're for. In this case, these longer screws would be used to mount the servo like onto something. So it would screw down here through the sides, these little mounting posts, here and here, to allow it to screw into like a piece of wood that it was mounted in, or a 3D print, or whatever it is. Okay, and this smaller screw, in this case it's black, not always going to be that color to help you identify it, but it's smaller, and it's meant to screw down. Once we put the servo horn on and it's in the right place and stuff, we will put this screw down in the center there. Move my fingers and you'll see. Basically screw it down in there to hold the servo horn on the servo so it doesn't pop off. Okay, so that's what those screws are for. So we'll put all the screws to the side here for a second. And we have our servo horns, we'll put all those to the side for a second as well. All right, so our servo here has this wire lead, right? And we have 3 wires in this lead. And to get the servo to work, we have to give it power, and we have to give it a signal to do something, right? So power is going to come from the darker two color wires. So in this case, it's brown and red. Sometimes it's black and red. We have our positive and negative, just like pretty much any car battery you've ever seen or things like that. Okay, so there's our power to power the servo. And the signal is going to come on that third wire. In this case, it's yellow. Sometimes it's white. But that is a signal wire to tell the servo where it's supposed to move to back and forth. Okay, so if I were to take my receiver and plug the servo into my receiver, I need to make sure I get those wires in the right orientation. Different receivers are different, but hopefully your receiver has some labeling on it. Most do. And you can see here, I'll grab another receiver as well. This one's a little bit more nice packaging, and you can kind of see here along the bottom perhaps, and if it's going to focus for me, there's an S, a plus, and a minus, so signal, power, and ground. This receiver happens to have it labeled on the back side of the receiver. I don't know if you can see that. It's kind of glary there, but there's a little chart that kind of tells you, okay, we're going to go ground, then 5 volts, then signal, so you know which way to plug things in. So this one says ground, then 5 volts, then signal. So that means the ground is going to be the pins that are on the very edge of the receiver on this side. So if I flip it over, okay, and I plug my servo in, I'm going to use that darkest color wire, the brown or black wire, is the ground. So I'm going to plug it in. I'm not going to care about channel right now. It doesn't matter where, but as long as I plug it in the right orientation, like so, we have our brown wire, then red, then yellow. Okay, or it could be black, red, white. Same thing. All right, so that's our orientation there. If we have a receiver that's labeled like this, let's see if we can see that. I'm not sure if you're able to see that very well, but it has signal on this side, then it says positive, and then ground on this side. Now it's kind of weird because it's labeled this way, but the pins are facing that way, so you kind of have to slide it over, like to transpose it onto the corner around here. So that's going to mean that the negative is on the bottom. Okay, so the ground or negative is on the bottom, then power, then signal, like that. It's going to be plugged in like that. Okay, a lot of you might have this type of receiver, and so just remember that kind of slides over. If you do have this type of receiver as well, you can kind of see there's a little teeth on the top there in the plastic, those little cutouts. If there are teeth on your receiver, they always go on the signal side. So if you didn't have a label on the receiver, but you had those little teeth cutouts in the plastic, a little bit hard to see. There you go, little cutouts on the top. Then you know, oh, well, the signal wire is supposed to go on that side where the teeth are at, so I know to plug it in this way. So hopefully that helps. Okay, put these away for a second. All right, so the first thing we want to do when we get a new servo is make sure we have the servo centered before we glue it into the plane. Okay, let me pull this example over for a second. This is kind of a mock-up wing here that I have. And this servo is not glued down, and neither is the control horn, but this helps explain some of these concepts, I guess. So typically when you're going to move something like an aileron, let me back up a little bit, like an aileron on your plane, you're going to have a servo do that for you. You're going to move your control, on your transmitter, okay? And it's going to tell the servo, hey, move, forward or back, or whatever you're doing. And if this was glued down and this was glued down, as you moved it forward, you would pull the aileron up. And as you move back, you would push the aileron away from you, or down in this case, since it's upside down. Okay? And so it's important before we glue everything in that we make sure that the servo horn, that little white piece we looked at earlier, is actually glued, or is actually set on the servo's center point, because the stick is spring loaded, so it's going to go to center if we're not pushing it. And when it goes to center, we want the servo to go to center, which will set up so that the aileron stays nice and neutral whenever it's supposed to be neutral. And then when we move the stick, okay, on the transmitter, we move that stick, we want it to move, right? But when we don't move it, we want it to come back to neutral. We don't want the plane to constantly be turning or climbing or whatever it's going to do if we're not pressing the stick, right? We want it to fly nice and level as it should, as a plane should. Okay, so to do that, we have to center the servo. So let me get our servo here. Okay, a lot of servos come pre-centered. Okay, so the step isn't always necessary, but it's always a good check. You don't ever want to assume that it's centered and then glue it in and go, oh man, I got to pull it, rip it back out of the plane and center it. So to center a servo, what you're going to need to do is you're going to need an ESC. Okay, this is basically just going to power your receiver and the servo. Whatever ESC you have should work fine as long as you can plug it into a power supply like a battery. Okay, I'm going to put the battery up here. We're going to plug in our ESC. Okay, there's no motor attached, so there's not really any danger right now or anything like that. It's just putting power in here, and then the voltage regulator, or BEC, is taking that voltage down from the ESC, or from the battery voltage, to the voltage we want for our servo, which is 5 volts. So I'm going to go ahead and turn my transmitter on over here. My transmitter receiver are already bound, so they're already talking to each other, and that's kind of what we want for this to work. So if they're not bound up, this won't work, right? But this receiver is already bound to this transmitter, which I have kind of off screen here. Okay. So I'm going to take my ESC lead. Okay, again, we have our signal, power, and ground, except in this case, it's going to be giving power to the receiver. Okay, so we'll take this and we'll plug it into our receiver. Again, we're going to make sure we get the orientation right. The ground is on the end here, so it doesn't really matter which port I plug it into for right now. We do want to save this one for one that we can control. So I'm just going to go ahead and plug my ESC lead into channel 2. Let's see here, channel 1. Channel 2 is at the bottom, so I'll plug it in down here. Okay, and you can see this should bind up here in a second. There we go, solid light, so it's bound. I don't know if you guys can see that light very well. Anyways, the receiver's bound, so now I'll take my servo, and one of the easiest ones to plug it into is channel 1, because that should be ailerons on most receivers, unless you have Spectrum stuff. Okay, so we'll take our servo, we'll plug it into channel 1, again, following that correct orientation. Okay, plug it in channel 1. I'll zoom in a little bit so you can see what I'm doing here. Okay, so I had the ESC I plugged into channel 2, so coming from the ESC there to power the receiver up. Then I'm going to take my servo and plug it into channel 1, making sure to observe the correct orientation of the wires, not plug it in backwards. Okay, and this receiver, the ground, should go towards the end of the board here. So ground wire towards that end, we plug it in. And you might hear your servo go and actually move a little bit when you plug it in. That's pretty normal. Okay. And now, since channel 1 is typically ailerons, I can take my transmitter here, I can move my aileron stick, and my servo moves. Sweet! Okay, it's working, it looks like it's okay. And it's kind of fun, you know, if you never played with robotics or anything, it's kind of like a little robot arm. Pretty fun stuff. All right, so now that my servo is plugged in, if I'm not touching the stick at all, and I don't have any trim in here, which, you know, if you haven't set up trim yet, you shouldn't have any trim in there, and you let go of the stick, it's going to go centered. Okay, which means the servo will get the signal to center. And that means we want to take our little servo arm here and place it as close as we can to 90 degrees to the servo body. So let's say we place it right, and there's some teeth on this little gear, so you can't always get exactly what you want. You're going to get as close as you can to center. That looks pretty good. You can tell it's not quite 90 degrees here. We can move it back and forth and see if the movement's about the same in both directions. We say, oh, I don't know, let's try the next gear tooth over. We can say, I'll move one gear tooth. Oops. And now we see it's a little bit more down. We say, well, which one do we like better? It's kind of a, you know, all almost the same there. I might put mine a little bit up. Okay, there we go. And now the servo is centered electronically. We put the horn on the right way. So at this point, we would power our servo down, so we're not twisting on the screw while it's powered. That can damage the servo. We'll unplug it. We would put the screw in right here, and we'd tighten it down until it was nice and snug. That little black screw, the smaller screw that goes in the servo horn. And that way the horn couldn't pop off. It couldn't come off center. So if you just put the horn on without knowing what was center, you might end up powering it up and saying, whoa, that's not going to work very good because you didn't center it. But if you have it powered up and you know where the center is, you can place the horn 90 degrees or as close as you can and get a nice center, so that way the horn can push and pull that rod basically an equal amount, okay? And it can move the control surface both up and down about equally, okay? All right, so the only thing you have to think about in this, I guess, last step here is how you're going to mount the servo. If you're going to put the servo and glue the servo in on this side to the plane, you know, for example, okay, that's great. The servo arm's sticking up. Let's say we're going to glue on this side where my finger's at. Servo arm sticking up, that's fantastic, okay? If for some reason you want to put it on the other side, you can also do that. You can center it on with the arm on this side. Get the same kind of, okay, that looks pretty good, you know? And you can put the glue on this side and glue the servo down this way. You say, Duke, why does it even matter? Well, typically the only reason why this matters is because the wire comes out of one end of the servo, and if this is like in the tail of the plane, you want the wire kind of facing forward towards the front of the plane so it can go up and plug into the receiver, which is typically in the middle of the plane. So if you were going to have this in the tail of your plane, you wouldn't want the servo to have to be facing this way if the nose of the plane is up there, because then you lose this extra a little bit of servo lead there. It makes it more complicated, get caught on stuff. So if you're going to mount it in like this, you say, well, okay, that's not going to work. Mount it in like this. Oh, but I need the servo arm to come out the other side. Then you would switch sides. So depending on your mounting position, you may need to put the servo on a different side, the servo arm on a different side. You can kind of see that here with this one. The servo is going to be mounted right here. I want the wire to go into this section here so it can go to the receiver. And so if I glue the servo down like this, I have to put the servo arm on this side. I can't have it sticking off that side because it would obviously go right into the wing and it wouldn't really work. So that hopefully helps explain. That's the only thing you need to worry about when you're centering the servo, is thinking, okay, is this servo going to go in the tail, or where's it going to go? Which orientation? Then you go, okay, the arm should go, this way, or it should go this way. Whatever way it's supposed to go, you can then put the screw in and tighten it down, keep it secure so it doesn't pop off or get moved on you. You can always recenter a servo if you need to, and the only thing that happens if you glue it in already, you got to rip it out. So try to figure out ahead of time where you're going to put them, and that way you can adjust the arms correctly. All right, that takes care of centering a servo. I'll do the push rod setup in the next video.